Hello students, today we are going to start our course of nuclear physics, and the first chapter in this course is nuclear structure and properties of nuclei. So before starting, I want you to know that nucleus was discovered in 1911, and it was discovered by Rutherford and his associates, and it was discovered as a result of alpha scattering experiment. एंड स्कैटरिंग के लिए जो मेटल यूज़ किया गया था, थिन फॉइल ऑफ मेटल को यूज़ किया गया, थिन गोल्ड फॉइल। मेटल कौन सा था? गोल्ड का मेटल था, गोल्ड था। तो न्यूक्लियस को 1911 में रदरफोर्ड ने डिस्कवर किया। एक्सपेरिमेंट कौन सा था? अल्फा स्कैटरिंग एक्सपेरिमेंट। अल्फा पार्टिकल्स वर scattered by the thin gold foil, and then Rutherford established that with the help of this alpha scattering experiment, Rutherford established that bulk of atomic mass and its positive charge resides in a very small central core of the atom, and this central core is called nucleus. So Rutherford, with the help of alpha scattering experiment, established that most of the mass of an atom and all of its positive charge, it resides in a very small core which is at the center of the atom, small central core of the atom, and that central core is called nucleus. So there are different hypotheses regarding nuclear composition, but we will discuss only two hypotheses. So our next topic is nuclear composition, and we will discuss the mainly two hypotheses. First one is proton electron hypothesis, and the second one is proton neutron hypothesis. In this course we will discuss these two hypotheses. So first of all we will discuss proton electron hypothesis. Proton electron hypothesis. According to this hypothesis, nucleus consists of proton and electrons. According to this hypothesis, nucleus consists of protons and electrons. But what are the reasons behind this hypothesis, or what are the ideas that led to this hypothesis? So first idea was that during a beta decay, electrons are emitted. ठीक है, जब बीटा डिके होता है तो इलेक्ट्रॉन्स एमिट आउट होते हैं, और इलेक्ट्रॉन्स कहाँ से निकलते हैं उस टाइम पे? न्यूक्लियस से, बिकॉज डिके किसका होगा? न्यूक्लियस का। जो डिके होता है बच्चों वो किसका होगा? न्यूक्लियस डिके करता है, और बीटा डीके के केस में इलेक्ट्रॉन्स न्यूक्लियस से एमिट आउट होते हैं. So this was an idea which greatly support this proton electron hypothesis. This was the first idea which support this proton electron hypothesis. Second one is when we study the atomic mass spectrum data. Second one is atomic mass spectrum data. It suggests that, ठीक है, जब हम masses को measure करते हैं different elements के, then it was found that atomic mass data suggests that mass of different elements was found to be nearly whole number multiple of hydrogen atom. ठीक है बच्चों, but when electrons were determined in each atom it fell short by large amount. इसको एक बार हम समझने की कोशिश करते हैं. For example, if we consider mass of one hydrogen atom, let's say this is given by x. So mass of one nitrogen atom would come out to be 14 times that of the mass of hydrogen atom. It was measured experimentally that mass of nitrogen atom comes out to be 14 times that of mass of hydrogen atom. Okay, now what हाइड्रोजन एटम में क्या क्या है बच्चों? एक प्रोटॉन है और एक इलेक्ट्रॉन है. लेट्स कम ऑन टू द नेक्स्ट पेज. In a hydrogen atom, there is one proton and one electron. Now we have 14 times the mass of hydrogen atom. So we can say that there are 14 protons and 14 electrons in a nitrogen atom. That is, mass of nitrogen atom is 14 times the mass of hydrogen atom, and a hydrogen atom consists of a proton and electron. So we can say that this is a mass of nitrogen atom is 14 times, and there will be 14 protons and 14 electrons. Okay, now experiments suggest that we already know that electrons revolve around nucleus. In an atom, electrons revolve around nucleus, and in case of hydrogen atom there are 7 electrons revolve around the nucleus. So out of these 14 electrons, 7 electrons revolve around the nucleus, but the remaining 7 electrons, it means they should be inside nucleus, because according to this hypothesis there are 14 protons and 14 electrons. Out of 14 electrons, 7 electrons are revolving around the nucleus, and remaining 7, so they might be inside the nucleus. It was a hypothesis. So these are the two ideas which supports this hypothesis, or which gives the idea that there might be presence of protons and electrons inside the nucleus. But there were some discrepancies and there were ideas or results which were against this hypothesis. So first we will discuss the energy of electron. We have to calculate the energy of electron if it would be inside a nucleus. Energy of electron in the nucleus. Energy of electron in the nucleus. So before studying this topic, I request you to please go through the de Broglie hypothesis of waves and nature. The nature loves symmetry. What de Broglie hypothesis. de Broglie hypothesis क्या बोलता है बच्चों कि अगर वेव है तो वेव में भी पार्टिकल नेचर होता है और पार्टिकल में है तो पार्टिकल का भी वेव नेचर होगा, बिकॉज नेचर लव्स सिमेट्री. That is wave nature. And if lambda is the wavelength, lambda is the wavelength of the wave associated with the particle, associated with the particle. देखिए डी ब्रोग ने क्या बोला कि अगर एक वेव है तो उसका पार्टिकल नेचर होता है. अगर वेव का पार्टिकल नेचर है तो पार्टिकल का भी वेव नेचर होगा. ठीक है, वेव का पार्टिकल नेचर और पार्टिकल का भी वेव नेचर. तो अगर किसी पार्टिकल के साथ वेव एसोसिएटेड है तो उसके साथ कोई ना कोई वेवलेंथ भी ज़रूर होगी, और वो वेवलेंथ को हमने क्या मान लिया, लैम्डा. लैम्डा वो वेवलेंथ है, उस वेव की वेवलेंथ है जो पार्टिकल के साथ एसोसिएटेड है. ठीक है, अगर वेवलेंथ लैम्डा है तो पी मोमेंटम कितना होगा, मोमेंटम वुड बी h बाय लैम्डा, where h is Planck's constant. H represents Planck's constant and P represents momentum of the particle. When we study particle in terms of waves, momentum of particle or momentum carried by the wave associated with the particle. Okay, now this was the de Broglie hypothesis. This was de Broglie hypothesis. Now if electron resides inside nucleus, if electron resides inside nucleus, its maximum wavelength can be lambda. It would be approximately equal to r. R is the radius of nucleus. If electron resides inside the nucleus, then wavelength of the electron, that is de Broglie wavelength of the electron, it would be nearly equal to radius of nucleus. Okay, so momentum would be given by h by lambda. This is the momentum of electron, and when lambda is equal to r, we have momentum is h by r. So putting the value of h and r, we have h is equal to 6.6 into 10 raised to power minus 34, and its units are joule second. Its units are joule second. And approximately for a light nuclei, for a light nucleus, radius is approximately, you can take 6 into 10 raised to power minus 15 meter, that is of the order of 1 Fermi. That is of the order of Fermi. So putting these values, we get P is equal to nearly equal to 1.1 into 10 raised to power माइनस 19 जूल सेकेंड मीटर इनवर्स। ओके, ठीक है जी, ये एसआई यूनिट्स में हमने कैलकुलेशन कर लिया। सो दिस इज द मोमेंटम एंड दिस इज फॉर एन इलेक्ट्रॉन। इलेक्ट्रॉन इज वेरी लाइट पार्टिकल। इलेक्ट्रॉन का मास कितना है? मास ऑफ इलेक्ट्रॉन इज 9.1 into 10 raised to power minus 31 kg. This is mass of an electron. For such a light particle, this amount of momentum is extremely high. ठीक है, अगर एक इलेक्ट्रॉन बहुत लाइट पार्टिकल है और उसका इतना मोमेंटम होना, इट मीन्स दैट पार्टिकल इज रिलेटिविस्टिक। जो उस पार्टिकल की स्पीड है वो रिलेटिविस्टिक स्पीड है। सो वी विल नाउ कंसीडर this particle behave like a relativistic particle if this is electron, and we are discussing the electron here. So now onwards we will calculate everything with relativistic formula. Let's come on to the next page. Okay, so what would be energy of an electron with such a large amount of momentum? It would be given by E is equal to P into C, and P is 1.1 into 10 raised to power minus 19. This is the value of momentum. And what is the value of C? C is the speed of light in vacuum, and this is 3 into 10 raised to power 8 meter per second. And finally it comes out to be approximately 1.3 into 10 raised to power 11 joule. And if we convert joule into mega electron volt, it would be nearly 200 mega electron volt. Till now we are considering nucleus to be light. Even if we have a heavy nucleus, in case of heavy nucleus, radius would be larger, and let's say the value of radius for a heavy nucleus is 10 raised to power minus 14 meter. 6 into 10 raised to power minus 14 meter approximately. We are taking here approx values, and then using this value of R, if we calculate the value of energy, then it would comes out nearly 20 mega electron volt. This is approximately 20 mega electron volt. So if electron resides inside the nucleus, its range of energy of electron should be range of energy of electron, it should be from 20 mega electron volt to 200 mega electron volt, as we have discussed now. But in any of the beta decay experiment, जो इलेक्ट्रॉन का एनर्जी है, it comes out to be maximum 2 to 3 मेगा इलेक्ट्रॉन वोल्ट. ठीक है बच्चों, यहाँ क्या हो रहा है, जो हम अगर आपका इलेक्ट्रॉन न्यूक्लियस के अंदर है तो उसकी एनर्जी का जो रेंज होगा वो 20 मेगा इलेक्ट्रॉन वोल्ट से 200 मेगा इलेक्ट्रॉन वोल्ट तक होना चाहिए. बट जो बीटा डीके एक्सपेरिमेंट्स हैं उनमें जो इलेक्ट्रॉन्स एमिट आउट होते हैं, उन इलेक्ट्रॉन्स की एनर्जी को जब मेज़र किया गया तो एनर्जी जो आती है 2 से 3 मेगा इलेक्ट्रॉन वोल्ट तक आती है. एनर्जी कितनी? 2 से 3 मेगा इलेक्ट्रॉन वोल्ट मैक्सिमम. ऐसा कभी ऑब्जर्व नहीं किया गया कि इलेक्ट्रॉन की एनर्जी 20 से 200 मेगा इलेक्ट्रॉन वोल्ट तक एग्जिस्ट करे. Such a large amount of energy was never observed in any of the beta decay process. So it means this rules out the possibility of electron lying inside the nucleus. So this suggests that electron cannot exist in the न्यूक्लियस. न्यूक्लियस में इलेक्ट्रॉन नहीं हो सकता. जो सेकंड फैक्टर है दैट इज न्यूक्लियर स्पिन। सेकंड फैक्टर क्या है बच्चों? न्यूक्लियर स्पिन। जब हम न्यूक्लियर फिजिक्स पढ़ते हैं तो स्पिन का मीनिंग होता है बच्चों टोटल एंगुलर मोमेंटम। टोटल एंगुलर मोमेंटम ऑफ न्यूक्लियस एज ए वोल। ठीक है, न्यूक्लियर स्पिन बोलेंगे। इसमें हम एग्जांपल लेते हैं ड्यूट्रॉन का। क्या एग्जांपल लिया बच्चों हमने? ड्यूट्रॉन का। ड्यूट्रॉन क्या होता है? ड्यूट्रॉन होता है न्यूक्लियस ऑफ ड्यूटेरियम। न्यूक्लियस ऑफ ड्यूटेरियम। And what is deuterium? Deuterium is the isotope of hydrogen. Hydrogen is 1H1 and deuterium is 2H1. 2H1 means A, that is mass number is 2 and atomic number is 1. This means mass number. So according to this hypothesis, there must be 2 protons and 1 electron inside the deuteron, that is deuterium nucleus. And this is also spin half particle. Both electron and protons are spin half particles. It means they can have spin either plus 1 by 2 or minus 1 by 2. So there are 4 possibilities. That is, first possibility, the spin of all the 3 particles, that these are called fermions. Spin half particles, you must know that these are called fermions. So इधर जो 3 particles हैं, तीनों का जो spin है इधर up, it may be down for all of the 3 particles. One possibility is this one and other possibility is this one. In this case, this is plus 3 by 2. Spin would be plus 1 by 2, plus 1 by 2 and plus 1 by 2. In this case, it would be plus 1 by 2. In this case, it would be minus 1 by 2. And here it will be minus 3 by 2. So, experimentally, when we will measure the angular momentum or spin of a deuteron, it must have value either plus 3 by 2 or plus 1 by 2 or plus 1 by minus 1 by 2 or minus 3 by 2. But this was not the case when measured experimentally. Let's come on to the next page. When measured experimentally, spin of deuteron comes out to be 1, which was against the spin calculated on the basis of proton-electron hypothesis. So this rules out the possibility of existence of electrons in the nucleus. Okay. Next point is magnetic moment. Next point is magnetic moment. तो बच्चों आपने क्वांटम फिजिक्स में ये ज़रूर पढ़ा होगा कि मैग्नेटिक मोमेंट associated with an electron is given by minus E by 2m. m के साथ हमने सबस्क्रिप्ट लगा ही which represents mass of electron and this L represents angular momentum. This is orbital magnetic moment of electron. Okay, this is me. And according to Bohr theory, L, that is magnitude of L, is given by integral multiple of h cross, where n is equal to 1, 2, 3 and so on, that it will take integral values only. So for a hydrogen atom, in the ground state we have n is equal to 1. So what would be the value of mu? Mu would be, that is, mu represents magnetic moment. It is minus E h cross upon 2 me. Okay, this is called Bohr magneton. Now mass of proton is approximately 2000 times the mass of electron. So when in this formula, when mass of proton is replaced by when mass of electron is replaced by mass of proton, so what will we get? Value of magnetic moment will be 2000 times smaller smaller than the value of magnetic moment calculated in the case of electron. And this was really the case, that magnetic moment of electrons is about 2000 times larger than the magnetic moment of protons. And as we know now that there are only protons and neutrons inside the nucleus. So if electron would have been inside the nucleus, magnetic moment of nucleus should be larger, or it should be as compared to that of electron, but this was not the case. Magnetic moment of electrons nucleus was very small. In fact, there was a huge difference between the expected magnetic moment of nucleus according to proton electron hypothesis and the calculated one. So if electron exists in the nucleus, the nuclear magnetic moments should be of the order of magnetic moment of electrons. That's right. But experimentally nuclear magnetic moments are found to be much smaller than the magnetic moment of electrons. Okay, so these are main points which rules out the possibility of existence of electron inside the nucleus. And fourth one, we can also state that the presence of few electrons inside the nucleus and few electrons revolving around the nucleus, this dual role of electron also make the study of this atomic and nuclear structure very difficult. So this is all for today, students. We will study the proton neutron hypothesis in next class. Till then, thank you.